Okay, here are the flashing kits that I talked to you about earlier in one of the earlier videos from moreleds.com. These are model train crossing flasher kits is what they call them. And the idea behind these is what I was going to do with them is just use one side of the flasher. It's made for like a railroad crossing where it alternates between two sets of lights, and I'm just going to use one side. I've already built one and tested it, and it worked out very well. It's variable speed flash, so you can set different flash rates for different circuits. So like this particular one, I've got it color coded to go to my main strobe lights, and you go ahead and build the whole circuit out, but I'm only attaching one LED to it, or one lead, and that runs all my other LEDs. And what I did on this circuit, if you've worked with LEDs very much, you know that you put a 470 ohm resistor per each LED, and if you have a bunch of LEDs in series, of course the resistance would need to be less because the LEDs present more resistance on the circuit. So to keep all that down from having to deal with all that, I put an individual LED, I put an individual resistor on each individual LED so that I could apply full 12 volts to each LED. And then on the circuit board, instead of installing the 470 ohm resistor where it goes on the board, I just jumped it straight across so that the full 12 volts is going out to the LEDs, and then the resistors that are attached to each LED takes care of that. So that's how I did that. And then I threw one of the LEDs in on the alternating side just to have, so when I was testing it I could see it working. That'll be inside the box, so you'll never see that flash anyway. So anyway, I'll go over the package contents and that kind of stuff, and I'll build one up real quick and show you how to do it. It only takes about 15 minutes to do one. So anyway, let's get to it. Okay, the first thing I like to do is get my little helping hands out, and let me get it lined up there for the camera so you can see it. Go ahead and just clamp it down, no big deal. Hold it in place. Get my package contents out. And let me zoom out here and I'll show you the paperwork. The paperwork with this kit is really good. That's overexposed pretty bad there. Let me turn that exposure down for a second. It has a really nice circuit diagram there, and then in the center it actually even shows you how each component goes together, and down at the bottom it shows you how to mount each one, what leg goes where, polarity, the whole 9 yards. So it's a very useful kit. The instructions are very good, and like I said, it goes together really quick. So what I do is get my package dumped out here. Oh, and another thing, if you want your kit to flash pretty slow, and for those lights on the ship, they don't need to flash very fast. They send you another set of resistors. The ones that go in there initially in the kit are 3,300 ohm or 3K3s, and then they send you another set of 33,000 ohm resistors optionally that you can put in there instead of the 3,300 ohm resistors that come with it. 33,000 ohm resistors, which offers more resistance, slows the circuit down even more, and it makes the flash a lot more realistic. So I installed those on mine, and they seem to work really well. So anyway, so to start out with, go ahead and put your small stuff on the board first. And in my case, since I'm jumping this circuit out and I'm not putting a resistor up here, this 470 ohm resistor right here, I'm going to use the LED on this side, because remember, you've got two that alternate back and forth. I'm still going to assemble everything fully, but I'm only going to really attach to this side to the model. So in that 470 ohm resistor right there that would set the load for your lights, we're going to jump that straight through, and we're not putting a resistor in that part of the circuit, because remember, we installed I installed the resistors in line with each LED, so I don't need to manage the load right there. So I'm going to go ahead and get that put there, and I'm going to go ahead and put my 33,000 ohm resistors right there where they would have been 3,300 ohm resistors. And all you do is just bend the leads down on the resistors, and you can put them right in the hole there. That's all it is. Get these little guys set in place. And I like to put several items on the board first and then solder them down instead of flipping back and forth every time. So we're going to bend that down. Set that guy in there. So I'm going to go ahead and solder these three things up. So what I'll do is I'm just going to, and this wire may give me a hard time, may try to fall out. I'm going to bend these over to the side so they don't fall out on me. So my soldering iron has warmed up now. Clean the tip off a little bit. And all you do is you want to hold the tip of your soldering iron to the copper and to the leg of the component, and you want to heat both items, and then just touch a little solder to it until it starts taking it, so it's all the way around there, and there you go, it's soldered. The ideal way to do it is you want to heat the objects and then touch the object with the solder so that it draws the solder in, not put it all over the tip of the soldering iron. Sometimes if you're having a hard time transferring heat, you may dip a little solder on the tip so that it gets good contact with the surfaces, so it will transfer heat better, like in that case. But that's it. Just heat it up and touch the solder to it. And those guys are in there. And you'll see it flow up the leg of the resistor and go all over the copper there, and you know you've got it. So now on this magnet wire, what I do, the heat of the soldering gun and the solder is supposed to take the varnish off so that it's conductive. But what I do a lot of times is put the soldering iron on it and rub it around a little bit to make sure I get that varnish off of there so it's making contact. You don't want to try to strip the varnish off every time you use this magnet wire, because that would take forever. The heat of the solder in the gun is supposed to take care of that for you. And so far it's worked for me very well. So I'm going to rub that a little bit, make sure I get that varnish off of there, get it heated up good. So I'm burning it off. Then I'm going to put a little solder to it. And you'll see if you're not making a good joint, the solder will pool around the wire but not be on it. It's kind of like a donut. So that means you didn't get everything heated up and bound together good. So put a little more heat to that. And that's what that was. It didn't get the varnish off of it. That magnet wire can be a pain in the behind sometimes, so see, it's still doing it. Really get some heat in there on it and burn that varnish off. That's the whole problem. I'll clean my tip. Grab that thing, stand it straight up. Another telltale sign is if you don't have a good solder joint, the solder will look dull and not shiny. That's a good way to tell that you don't have a good joint or a good connection. So there we go. Flowed in there that time. Okay, and then once you get your items soldered, just take a pair of side cutters, snip them off at the board. You want to keep your components down as close to the board as you can. Some circuits aren't as critical, but you can get RF running around on the board if it creates, if you got an oscillator or something like that, it can create noise on other electronics and stuff like that. And if the items are too long or too high off of the board, they become an antenna and a transmitter and all that mess. Good common practice is to put it as close to the board as you can. So okay, we got our resistors in there. We've got that jumped out now. Now we're going to go to our, we'll go to our transistors. And if you notice on the transistors, they're triangular shaped, the 3 holes. And if you look at the drawing shows you just how to do it. The center leg goes out, kind of, see if is that in the picture there? Yeah. Need to turn that gain down. That's a little bright. Sorry about that. My light's changing a little bit because I'm moving the camera around. What I do is I just take that center leg and poke it out. Let's use a little toothpick there. What I do is I just poke that leg out a little bit and then put a right angle bend on it. Be careful not to cut it. Straighten the legs up. And you can see I've got it shaped to go into the holes. And then all you do is kind of bend them a little bit, put them in the holes. There you go, you got your first transistor in, just like it shows on the drawing. Okay, so I'll go ahead and do the second transistor, get that guy in there. And it even traces the outline of the transistor, and as long as you follow that outline, it shows you what direction to put it in all. I mean, you really can't mess this up if you pay attention. You don't have to be an electrical engineer to put this together whatsoever. Just some minor reading skills and you're there. All right, put the second guy in there. And another thing too, when you're soldering, make sure you get the heat in there and get it soldered and get off of it, because it you don't want to bake the electronics. I'm just going to move this thing back into frame there when I flipped it over. Now we'll go ahead and solder the legs on the transistors. Good and hot. Draw that solder in there. And the reason I looked at this kit was I was looking at different things, and they were all so specifically or purpose built. And I came across this website and saw this kit and thought it had a lot of potential to be customized and used any way you want. So I thought I'd give it a shot, and like I said, the results were really good on it. When I turn it on later, when we're done with putting it together, I think you'll be fairly impressed with it. I was, especially with the simplicity of it. Cut the ends off of there. Let's flip her back over, get it back in frame. There we go. Okay, now I'm going to go ahead and put the 2 capacitors in there. And if you'll notice on the board, there's a plus sign. And on your capacitor, if you'll notice, on one side there's a minus. There's your negative. So what you do is, and it also is a giveaway that the long leg on the capacitor is the positive. So make sure you have the polarity correct, and it even says so in the drawing schematics that come with it to watch and be mindful of the polarity. So we're going to put our 2 capacitors on there. There we go. We got the minus side. So put the plus in the plus, the minus in the minus. There we go. Those guys are in there. Try to get them nice and straight. Now we're going to flip it over. Get those 2 soldered. I'm running out of solder here. I bet I've used 100 feet of solder in this thing with all the wiring that went into it. Okay. So we're going to go ahead and heat that up. Make sure my big head's not in the way. I didn't look before. Okay, got that leg. Okay. Let me make sure those are in there good. They look good. Go ahead and cut them off. I'm probably out of frame at this point. I'm fixing to flip it back over though. Okay, so we got those in there. Now the last component we need to put on the board is your pot or potentiometer, rheostat. There's a lot of different names for it. What this does is it's a basically a variable resistor. The resistance value changes when you turn it, and it shows 2 ways to install it in the instructions. Let me see if I can get that in there. Can you see that? Let me turn the gain down. It's probably too bright. There we go. You can mount it vertical. You can bend the legs and mount it vertical, or you can put it like it is and mount it horizontal. And I just do mine horizontal. And if you look at the picture there, it shows you what holes to put it in. It's very simple. So I'm going to go ahead and mount this one horizontal. So turn that gain back up. Make sure we can see everything. So going to put the 2 legs in there, and that one goes right in the middle there, and that's it. Get that guy in there. And of course somebody wants to start using the skill saw while I'm shooting a video. Thank you, guy. This old house. Let's see if we can get it flipped over. Now this one I'm going to have to hold it in because it wants to spring out. So let's get those legs soldered in there. Get it flipped over where you can see it. I'm doing everything backwards on the camera display. Okay, you can see the 3 little legs sticking through there, and it is wanting to behave. So I'm going to go ahead and stick one down before it decides to pop a wheelie on me. Alright, got that one in. Got that guy in. Got that guy in. Nice thing about those, they're so short you don't have to cut them off. Okay, so that's the finished circuit as far as the components are concerned. Now let me look at my wiring diagram that I made up for my ship, and this one is I'm gonna do this one for my nav lights. So those are blue wires. Let me grab a scrap of blue wire, and all I'm using for my main cabling is just data networking cable, some Cat 5 cable. It works pretty good. Okay, if you look at the LED slot on the board, make sure my finger's not in the way, you'll see a flat bar across on the bottom of that little logo. That is your negative side. On mine, I'm using the white of each pair. So white, blue, white, orange, white, green. Those are my positive. So I'm going to go ahead and put the white, blue, do it so you can see, white, blue in the positive side. And this one may take a little more heat because of that copper wire. It's pretty big. No, it took it right on. There we go. All right. Then I'll use my solid blue. That's where an LED would go, but what I'm doing is I'm doing jumper wires to go to the other LEDs that are already in the craft. So, all right, there we go. Is that in frame? Yes, it is. Let's go ahead and hit that. And this goes a lot faster when you're not trying to shoot video and make sure that people can see what you're doing and that kind of thing. And I know probably most of you have done this, and this is no big deal, but I'm doing this for someone who may not have ever done this before, and it may help them, because I know I learned a lot on YouTube, so I figured I'd just pass it along, anything I know. So, all right, there we go. I'm gonna go ahead and clip those off. Probably got some electronic technicians watching what I'm doing, going, holy cow, this dude's awful. So I'm gonna go ahead and do the other side, same way. Okay, yeah, and I didn't, let me explain that. Okay, that's the part that goes out to the string of LEDs. Now, if you'll see on this side of the board, it says 9 volts. Don't worry about the 9 volts. That's just because they designed it around 9 volts. This works fine at 12 volts. I think it goes from like 7 to 16 volts or something like that. But you're going to put your positive and your negative from your 12 volt power source right here. So I'm going to go ahead and do the same thing. I'm just keeping the colors the same so I know what I'm hooking to. It doesn't really matter what's on this side. It could be red and black, or, well, I mean, since you're using DC, you should use red and black, but it doesn't really matter. Here we go. Am I in the frame yet? Let's go ahead and solder that guy in. It's going to fill the hole. The wire's taking it up first. There we go. She is in there. We'll get that hooked up. And if you hear that, that's my phone going off saying we're under a severe thunderstorm warning, which is a daily occurrence right now. Okay, so that is the complete built circuit, ready to go. I mean, it doesn't get any easier than that. So now I'm going to hook it up to the model. Let me trim these last couple of wires off that I put on for the power. So we've got the whole kit put together. Now what I have is, where is my kit? I just have this 18 volt pack. It came with a fancy LED kit from the auto parts store that I used in as a controller for another kit that I built. But it comes in real handy for testing. It's actually 18 volts instead of 12, but it does the job. So it's just a pair of 9 volt batteries is all it is, with a little momentary switch, thumb switch. So anyway, I'm gonna connect this up. Red to the positive, black to the negative. Okay, now I've got the pigtail coming from the craft, and remember it's blue, and since I color coded everything, I know which one to hook to what. So I'm going to go ahead and hook the blue positive up to the craft, and I'll solder all these connections when I put it together permanently inside the box. So there we go. We've got 12 volts coming in, goes through the circuit and out to the craft. And remember, all of the LEDs, the individual LEDs that I put in, the mini micros, they all have a resistor on them. So, and I forgot, you have to complete the circuit out. I didn't put the 470 ohm resistor and LED on the opposing side, and I need to, so I'm going to go ahead and do that now, and then when I come back, that'll be ready to go and it'll actually flash. I got the resistor put in and the other LED. Everything's installed and ready to go, and they are flashing. Earlier when I turned it on, they didn't flash. They just came on steady. I'm like, what the heck's going on? And I forgot I had to complete the other side of the circuit for it to be able to flip back and forth. So what I'll do is I'll turn the lights off and see if that's showing up on the camera. I'll zoom in there for you. And if you hear the guy hammering, that's old Norm Abrams or somebody next door going crazy. There you go. Turn the gain up a little bit here. The video will probably be a little noisy, but you'll be able to see it. And that's it flashing. Now I can tweak the speed by adjusting that pot that I told you about with your finger or a screwdriver. And if you look at it now, it's a little slower, and this is all the way down. That's as slow as it goes, and then I can spin it back the other way. And the reason I used the alternate resistors that came with it, because the other ones were just way too fast. See how much faster that is now? So this is a great circuit, and they're very reasonably priced, and if you want to make lights flash on your ship, they work really good for that. Now they won't get fancy and do the strobe action where it's like a quick on and off, pause, quick on and off, pause. It's evenly spaced between on and off, but I think it does the job well, and it's really simple. So anyway, I hope you guys got something out of that, and I hope it helps you with your build. And the next time I come back, I should have everything painted and getting decals on it and getting her finished up. So thanks for watching, guys.